Hello guys, yes, I hope you are fine. Me too, I'm doing well. And so guys, let's look at this question guys. And as you can see, that question, it is we use what we call integration by parts. And the reason why we use integration by parts guys is because this equation consists of two functions that are different. For example, we have x cubed here and we have sine x. And so guys, these are two functions because you cannot be able to mix, not to mix, but you can't be able to multiply x cubed by sine x. I mean, it will still remain like that. Unlike where you could have x squared and then x cubed. For that one, you can be able to multiply them and then they become one unit. For these ones, they cannot become one unit. So, because of that, you employ integration by parts, more like the product rule in differentiation, whereby if we have something like that, we apply the product rule. But for the integration, we employ the integration by parts. And so guys, let me start off. And the first thing, we write the equation for integration by parts. And here is the equation. Supposed to be integral u dv equals to uv minus, now you exchange, instead of writing u, you write now v now du. So guys, that is the integration by parts equation. And so guys, we come here and select, here we select probably x, we say x cubed, we give it u, and then sine x dx, we give it dv. And now guys, as you can see, this is our first term. This one is equals to that. And so what we are now going to look for is uv and then minus integral v du. And so let's do that guys. I'll come here and say I find the du all over dx. Guys, instead of writing dx down here, I'll write it after now finding the du dx for that. That is 3x squared. Then I can write my dx, instead of writing here, I write here dx. So guys, I hope that is understood. And then guys, I now come for v. When we come now for v guys, we are actually integrating. So I integrate sin x. That one now gives me minus cos x. And guys, it's always good to test by reversing, because when you reverse, you are able now to know whether you are correct. For example, if I were to do dv dx, of course, usually it becomes a negative. And that's why I have put another negative here. So that if I say cos dv dx is minus, so it will be cancelled by this minus, and then it is sin x. And so guys, from there now I come and now replace my figures here. So I can even write that equation first. X cubed sin x dx now equals to, I come write u is here, which is x cubed, and then the v is here, which is minus, so I will have to put a minus there. Then I put cos x like that, then minus integral of v. My v is minus. Because of this minus and this, I can now change this one to be plus. So now I will have cos x, and then we have the du, which is 3x squared. 3x squared. Guys, you can see now we have removed the negative that was there because of the cos had a negative. So from there, guys, we come and continue again. Now I will come and say, I'll give this one, we have a dx here, guys. I was about to forget it. So now, guys, I will select once again. I will say this one, I give it value u, that one, and this one, let me give it now dv, like that. So guys, now I can say the du all over dx. The dx I will put is this other side. This one now is going to give us 6x dx, like that. I hope I have differentiated well, because you bring 2 here is 6, then there remains 1. And then now we come and find the v. The v we are going to integrate cos x. That one now gives us sine x. And that one, cos x dx, gives us sine x. And you can differentiate sine x, you get cos x. So guys, up to there we are quite okay. So guys, I will write my equation again here. Let me just write the whole of it. I continue to carry it forward. X cubed sine x dx, this now is equal to minus x cubed cos x plus. Now guys, when it comes here, I come at this point, I don't need to repeat this again. What I need now to write is my u, my v, and then this. Because remember, this one is equals to this. So I'll come directly and write for u. U will be 3x squared. That is for u. And for v, we have sine x. Now I'm finished with that. I now come to this point, where now I'll need to write in the minus again. Maybe I can write it here, down here, guys, because the space is too small there. So let me make it plus here, so that now if I write minus here, it will not change the fact. Because if I write minus here and the minus, it will then mean that the whole of it will be negative. It will be positive. But because it's minus, I can write minus there. Then I draw my integral sign. And then, guys, now we come and replace our v now from this. The v is sine x, and the du is 6x. So we have here 6x, and then we have the dx, like that. Guys, up to that point, we are doing well. So what I'll do, guys, I'll come and now, because it is so long, I can now omit this one, knowing that this is now our question, and just write our answer here, of which we have not yet finished doing it. So I write equals, but we know this one is there, equals negative x cubed cos x. This is plus 3x squared sin x, then minus. Guys, I come now here. I will write, I can put a bracket here because anything that will go beyond this negative will affect whatever will be there, and that's why I have put a negative. I have put a bracket there. So now I give these values. I can rearrange them first, then I give them values. I'll write 6x here, and then sin x dx. And the reason why I do that, guys, is because even as we continue to integrate, you can see this x, the power that raises x continues to go down. Otherwise, if I give this one v, then it will go back to our original value. And that's why, guys, we are choosing this one to be represented by u instead of dv, because we want to finish this x, and so that we shall be able now to integrate a value that is easier without x. And then this one we give it dv, like that. So guys, now our du then will be equal to, this one now is going to be 6, then dx. Then our v is now going to be minus, if you integrate sine, you get minus sin x dx, you get negative cos x, like that. So guys, now we are almost at the end. So now guys, I'm going now to put my equal here. Then I put negative x cubed cos x plus 3x squared, then sin x, like that. Then guys, I have a minus here, so let me just put a minus there and the bracket there, and then I go now to our original equation, whereby guys, we have this value is represented here. You can see here. So whatever now we are going to write before, after, it's going to be this. So now we need u and v. So guys, let's now look at u and v for this. U is 6x, so I write there 6x. Then I write negative cos x, which is now v. From there, guys, we are now going to have minus integral of v du. So v is negative cos x, and the du, that is du, is 6. Remember that this 6 is alone like that. It's not multiplied by x. Then we have the dx. So with that one, guys, now we come almost to our conclusion. So guys, I can now write the answer, and this is now going to be our answer. Let me see. We have negative now x cubed cos x plus 3x squared sin x. When we come here, guys, we multiply minus to the inside. This one now is going to give us plus. So guys, here we are going to have plus 6x cos x, like that. And then guys, after that, Here we have minus and minus. This minus and minus will end up being plus. But now we have still another minus. So finally we shall have minus. Now 6. And then we integrate cos. When we integrate cos, already now we are going to have sin x. So that is now, guys, this is now becomes our solution for that. I hope there is no problem with the sign. Because even before we integrated, we had already put a negative. So we are only dealing now with the cos. If you integrate cos, you get sine. Because if you differentiate sine, you get cos. So guys, this is our solution for that. And so guys, thank you for listening to me. Bye bye.